All right, guys. So yeah, I never apologized for making those previous videos in a widescreen aspect ratio. So yeah, you may have noticed that the last video I switched over to a 16 by 9. So I apologize if that caused any issues with viewability for people that are on a 16 by 9. I have switched my monitor over to 16 by 9 now, so that's what I'll be recording, and I just simply forgot to do that before I started recording those initial videos. But anyway, moving forward, we're going to talk about copy bone motion now, and I'm going to go over that with you. So for the data asset, the PDA copy bone motion data asset, basically what I did is all the categories, all the things in here that we're going to bind to that are under a category, I put them under the same category inside of here. As you'll see, this one's under copy category. So for the copy category, we're going to add a float for delay and a bool for the use root space. Now, normally you're not going to rotate the root before you get to this stuff. You shouldn't be, but there may be some situations where you end up doing that, or you need to do that for some weird reason. So let me just kind of break this down for you here real quick. I'm going to maximize this, and I'm going to come over here. And let me kind of explain to you exactly what mesh space actually is, because a lot of people are confused and they think that mesh space is relative to the root, which it is not. So the root is in mesh space. So if I add 100 centimeters along the Y to the root, you'll see that it has been moved forward 100 centimeters relative to the root of this scene. The root of this scene with which this skeleton is residing in, that is mesh space. Don't get that confused by by world space, because when you have it inside of a character, it's actually attached to this component here. So this component, the root would be relative to this component. It would basically be the same thing as component space. It seems like it's starting to storm, so hopefully that doesn't get too loud in the recording. I will do post-processing to hopefully clean some of that up. Anyway, so moving forward, it's important for you to understand how this stuff works. So I've offset this root bone 100 centimeters forward in mesh space, okay? So if we come over here to the pelvis, you'll see that the pelvis is 2.37 centimeters along the Y relative to its parent, which is the root, because that's what it's attached to. It's the child of the root. And its offset relative to the root is 2.379462. It's also 98.69 centimeters above the root. And then it has its own rotation relative to the root. Okay, so if I move over into mesh space, which would be world space inside of this scene, then you'll see that the 100 centimeters that this root is from in mesh space. The root is 100 centimeters of mesh space. That gets added to the 2.379462. So if we move the root up 100 centimeters, you'll see that the pelvis location in mesh space is actually 1.9869. But if we switch back over to local space, you'll see that it's still only 98.69. So that's basically how it works. This also applies to the rotations themselves. So if I were to rotate this root, then the pelvis, which in local space would still have its same rotation, but it would have a different rotation in world space, depending on the rotation of the root, you see. So it's important for you guys to kind of understand that a little bit. So what I'm going to do is I'm going to show you what happens is if you have the root rotated 180 degrees, before we do that, let's just come back over here, say to the spine, and I'm going to copy that in mesh space, and now I'm going to rotate this 180 degrees. So if we were to rotate the root 180 degrees, and then we were to apply something in mesh space, then this is how it would come out. You see? It's going to respect the actual orientation of that bone relative to mesh space, regardless of what it's attached to. So it's important for you to understand that, because that's basically what those options are for. Whenever you see them on these nodes, use root space, it's going to take root space rotation into consideration rather than just assuming mesh space. The reason why they ended up having to add that stuff is because with the game animation sample project, they took a route where they were manually like rotating and offsetting the root bone, so that kind of broke the traditional mesh space approaches to things, which is why they ended up having to come back and add all that stuff to a bunch of nodes where you might need to do that. You see. So moving forward, because I'm burning through time here, let's go ahead and go through the rest of this, and then I'll come back and I'll explain to you exactly how the different stuff on here works. So under the translation, everything's pretty much self-explanatory. The translation offset is actually a rotator. The translation scale is a vector. The translation smoothing time is a float. The translation remap curve is a curve vector of object type. So you need to make sure you understand that, because there is a vector curve, which is a struct. You don't want that. You want the object type called curve vector for the translation remap curve. For the rotation, it's different. It's a curve float of type object type. And again, I believe there's a struct of type float curve. Yes, so don't get those confused. You don't want the struct float curve. You want the object type curve float. And then under the curve, we have the target curve scale, which is a float. That's for this curve. It outputs a curve that you can use, leg IK. Well, let me rephrase that. So it'll output a curve that leg IK can use, which will basically drive the elbow orientation during the IK. It'll allow you to add motion to the actual movement of the elbow. So it makes the arms look less stiff, basically. You don't have to use that, but it's there as an option. Now I'll go ahead and go over these last few. So this right here is actually just for the be enabled. I'm binding it to that. And then we have the copy motion weight, which is assigned to the alpha. And then we have a debug mode, which isn't apparent at first. But if you come over here, if you didn't know this, you can type in anim node, and you'll see that we have all kinds of debug stuff that we can enable that require you to enable via a CVAR. And that is how you can enable the debug options for the copy motion, copy bone motion dot debug. And if you hover over it, it'll tell you what your debug options are. So the second one will not work during runtime, from what I've seen. The second one seems to only function properly from the preview instance mode inside of the anim graph while the game is not running. So the preview instance it works with this anim preview editor, and it allows you to preview the actual animation by changing these values from inside the graph, so that you can actually like debug without even running the game, and you can slow it down or speed it up and so forth. And we'll this is how we will be configuring the copy motion settings. We're not actually going to configure it while the game is running. It's going to be a lot easier to do that from this mode here, because you have a lot more control. Now, this may be a bit more difficult for you to do if you're using copy motion. I don't know. I haven't tried doing it this way with the gas project yet. All right, so that's basically all the data asset variables that I added. And over here on the anim graph, basically what I'm doing is I'm seeing if either one of these has a value other than 0, then we'll update that console command. We'll execute a console command that will update it to be whatever value is not 0 between these two. And that brings us to our PDA layering settings. So on our, actually, yeah, let me just go ahead and go over this with you real quick. Basically, on the PDA layering settings, we're referencing a PDA bone mask and a PDA copy bone motion. And then we're doing some other stuff here, and I'll go over this stuff in the next video. Ignore the fact that this is called handr underscore whatever. But yeah, it kind of helps let you know that it's for the handr in this situation. So moving back over here, this will allow us to enable the debug options from the actual data assets themselves. So if I come over here to the resting state, he is in the resting state right now, and I open up the CBM, which is the copy bone motion one. I'm just going to move this over here. If I set this to 2, okay, it's doing it again. I've been having problems with this, like randomly working and not working for some weird reason. I think it has something to do with this right here. When you're in preview mode, I don't think this stuff is actually getting executed. Sometimes it does, sometimes it doesn't. So let's see. See, it was working fine yesterday, and now it's not. I don't know why. Okay. Anyway, you can always just enter them through here. Yeah. Anyway, I'll go over that debug stuff with you here after a while. But I don't want to spend too much time on this. My goal was actually to make this video series shorter, and it seems like I'm probably going to end up taking up as much time as I did before. So let's go ahead and break this down, because this aspect of it, the copy bone motion, is where a lot of confusion sets in if you don't understand things properly. So I'm going to have to spend a good amount of time explaining this portion of it to you guys. So we'll start at the top. Use base pose. So there's two modes with the copy motion. You can either drive copy motion via curves that were baked onto the poses themselves, or you can drive it by evaluating the actual state of the game or the state of the pose on the anim graph during runtime. So it's going to be a lot more flexible if you use base pose. If you use base pose, it's not going to check for the curves. I'm not going to go over this aspect of it, but if you move over it, it says format matches those curve prefix used for the animation curves. Format matches those generated by the layering motion extractor modifier. So if you come over here and you go to anim modifiers, there should be one in here called layering motion extractor modifier, but I don't see it. I only see the motion extractor modifier. I believe you can use this one, but I'm not seeing the relative to bone name. It's grayed out for some reason. And I'm not real familiar with this. So I'm not going to go over that with you guys, but that's basically how you would bake it down here. And let's say I just apply this. The prefix would be root, and then the rest of it is underscore translation underscore Y. But if I did this, yeah, it's going to. Right, so if I had more than one, the prefix for all of these would be root. That's what it means. So I'm going to remove this and delete these because curves do have do add overhead. And so right here you would just type in root if that was your prefix, and then it would just automatically grab all the translation and rotation curves off of that it needed. But for this case, we're actually going to be using base pose. Did I just mess that up accidentally? I think so. I think I had that in spine 5 space. So now if you're using the base pose, I don't think that the delay works unless you have use base pose checked. If you're taking this route, then I believe that's the only time that the delay will actually work. So the delay, basically what you're doing is for the source bone and the copy space bone, you need to track these two bones and with pose history. And so if you have any delay, it'll stop evaluating this base pose right here, and it'll go over to your pose history, and it'll start grabbing those from your pose history back in time from, like half a second ago. It'll get the values of these from half a second ago. And then over here, it'll take those two poses from half a second ago, and it'll see how far they've moved from this base pose reference, and then that will be the motion that gets copied. That'll be your delta, the difference between those, which is why your locomotion needs to be plugged into the base pose, because if you disable this delay, then it's going to stop grabbing those bones from the pose history, and instead it's going to be grabbing them from this base pose. Now, from what I've seen, regardless if you have delay enabled or not, it's still going to be evaluating this base pose. I'm not completely sure why, but that seems to be the case. It'll be evaluating all of this, regardless of the fact that it's not actually using this one while the delay is active. So let me go into more depth on how the actual delta is calculated. So the delta is calculated between the base pose and the base pose reference. And I actually made some notes here. Let me see. Right. So it's going to look at the source bone. It's going to look at this source bone, and it's going to in the base pose, and then it's going to look at the source bone in the base pose reference. If you have delay, it's not looking at the source bone from the base pose. It's looking at it from the pose history, back in time, however far back you set your delay. So, and then it's going to compute the difference, what motion happened. So it's going to compute the difference between those two poses. And that's why this is a neutral pose. So if we come over here, so in the locomotion animation, the arms are swinging forward and backward while he's running, right? So if we used this pose as the reference, it would say, hey, when the hand's back here, what's the delta between where it's at here and where it's at over here? And you see how big that difference is? Now, when the arm is forward, that difference is going to be a lot smaller. You see, that's why we use a neutral pose. So the neutral pose is just a pose where his hands, are kind of down by his side. So if we open this one up, then you'll see if the hand is up here, then you'll see it's going to be a positive delta. And if the hand's back here, it might be a negative delta. But the difference won't be real huge. You see, that's why we use a neutral pose, because it evens the differences out in a predictable manner. And also, all of our poses are made from this idle pose. So that helps too. So hopefully now you understand how it's actually calculating the motion. Let me go through my notes some more with you guys. So the copy motion, how did source bone move from the reference pose to the base pose? From the reference pose to the base pose, or from the reference pose to the pose history pose? The change in location from the reference pose to the base pose, or the pose history pose, determines the copy delta. The copy space, how did the source bone move relative to this other bone? Otherwise, component space if you have not assigned a copy space bone. So if the source bone is hand R and the copy space is, say, spine 05, then it's going to say, how did the hand R move relative to the chest? If the chest rotated 45 degrees and the hand rotated with the chest, in component space, the hand moved a lot. But if you're copying the space in spine 05 space and the hand didn't move relative to the chest, then no movement is added, you see? So only how far the hand moved relative to the chest is going to be added. And that's the reason why under most situations, you're probably going to use the chest or the shoulders, the clavicles, if you will, to dictate the delta. Like you want the difference to be relative to either the chest or the shoulders. You don't want it to be, relative to, the head or the pelvis or the root or component space. Especially if you're rotating your root before this, you definitely don't want it to be relative to the root. Relative to component space. You would then want it, at the very least, to be relative to the root. But like I said, you're almost always going to want it to be relative to the chest or the shoulder. That's going to give you the least dramatic deltas, and they're going to be the most usable deltas. the apply space. The move or rotate the target bone as if its axes were aligned to apply space. Otherwise, it's going to assume component space. And if you move your cursor over this, it'll tell you if no reference frame is used. It's basically saying if you haven't assigned a bone to this, that's what they call a reference frame. If no reference frame is used, the source bone motion will be applied in component space. We should probably at least have this set to root, just in case we end up needing to do that. Because of, for obvious reasons, I explained to you why you need to keep that in mind. So if the bone to modify is VB hand R and the apply space is root, apply the motion relative to the root. So 50 centimeters along the Y will offset the virtual bone hand R 50 centimeters forward relative to the root along its Y axis. If the apply space was hand R, it would offset it 50 centimeters along the hand R's Y axis. So I'll go ahead and show you over here inside of this. And this just brings us back to what we were talking about before. 1 meter forward, 100 centimeters forward relative to the root would be in this direction. Same if it were in component space, as long as the root isn't rotated. So let's see. If, however, so yeah, let's do it this way. So it would be 100 centimeters forward like that. But if we move it relative to the hand, which would be the parent of this socket, then 100 centimeters would be over here somewhere, you see, instead of forward. So Y would be in that direction instead of this direction. Let me make sure, did I reset that? Yeah. And that's going to basically, affect how your translation scale operates. So if you want to reduce the movement in the forward direction, then you would want this apply space to be either root or component space. And remember, if you don't assign this, then it's automatically going to be in component space. Otherwise, if you set this to hand R, then it's going to move in that direction that I told you before, where Y is moving off over in this direction. Y would be along this axis. When adjusting the Y of the translation scale. Translation offset and rotation offset and pivot don't work like you probably think they do. I'll try to explain how these work as best as I can. Those are going to confuse people. Okay. So how the delta is calculated. Copy space is where the motion is measured. Apply space is where the motion is applied. How the motion is applied, Apply space basically dictates the direction in which the apply space is going to affect the way the motion is being applied. The source delta is the source and base pose minus the source bone and base pose reference. You can replace base pose with pose history if you're adding a delay. And then the copy space delta is going to be the copy space, and base pose minus the copy space and base pose reference. And then the final copied delta is going to be the source delta minus the copy space delta. Now that might not make a lot of sense, but that's based on the C++ for those who are interested. Now, the translation offset, you can read the tooltip. It says the offset to use before applying the translation deltas in degrees. This is useful for changing the direction of the motion relative to our reference frame bone. So it's going to basically reorient it around an axis. Okay? So whenever you apply that, it's going to look like it's moving around in circles. But in doing so, it's going to affect the actual direction in which the motion is applied. The scale allows you to adjust what the percentage of that motion along that axis gets applied, and that axis is the direction of each axis is going to depend on what your apply space is. The translation smoothing time, it's basically just going to smooth the translation, and that comes down to this right here. This is new, I think. I don't think this was in the original plugin they released. There's other things in here like the use root space. That was not in the original one, I don't think. I'm pretty sure it wasn't. So there are some new things in here with the release of this plugin for Unreal Engine 5.8. So the delta smoothing is disabled by default. If this is disabled, then the smoothing time will be applied to the overall translation, which means the translation itself, it'll look like the translation is lagging behind. So if you jump up and as you're falling, your hands are going to start rising up in the air. And then when you fall, they're going to go down below your pelvis. That's how it's going to work by default, which is normally what you don't want. So you want the delta smoothing. Delta smoothing, what that does is it actually smooths the delta of the motion itself. So you're actually smoothing the copied motion before it gets applied, which prevents that issue that I just described to you. The translation remap curve, that somehow allows you to remap like the translation itself. I'll have to get back to you guys on that. I have not played with this yet. Same with the rotation remap curve. I have not experimented with that yet. The rotation offset, and I'm going to actually show you this with the debugger here in a second, how this stuff actually works, so that you can see it in while it's happening. So the rotation offset in degrees, the rotation offset in degrees to apply before the rotation deltas. So again, before the rotation deltas are applied, it's going to offset it around an axis, basically. This is useful for changing the direction of the motion relative to our reference frame bone. In this case, it's going to change the direction of the actual orientation of the bone to modify. In most situations that I've seen, you want to use very little rotation whenever you're copying rotation over. You can set the rotation amount, which is the rotation scale. You can set that high and then come back later and reduce it with the copy bone advanced. I'll explain to you guys how this works, because it took me a minute before I realized exactly where this became useful. The rotation smoothing time works just like the translation smoothing time. And then down here, we have a target curve name. We have to specify this. So right here, I called it copy motion underscore R. You could just call it CM underscore R for the right hand. And then over here on your leg IK, you're going to set your twist offset curve name to be CM underscore R or copy, whatever you named it over here. The target curve scale, it'll scale it up and down just like the translation and the rotation. It'll scale whatever value the curve is given, it'll scale it up and down. And then your target curve component, I've had a lot of issues with the rotation angle, which is the default. It's defaulted to rotation angle X. I'll have to get back to you guys on that because I've had some issues where the quaternion flips between a positive and a negative every couple of frames, and then it'll flip back. And what that ends up happening, it ends up doing is if your elbow is pointing down, suddenly it'll be over here. And then it'll go from being over here to being back down here. I'm not exactly sure why that's happening. It's basically happened in almost every setup. Sometimes it'll look like it's not happening, but then as soon as you jump, it seems to do it again. And the rotation angle, though, is closely tied to this copied rotation, so that might have something to do with it. I would recommend using the translation Y. Under most situations, it seems like the translation Y ends up coming out looking the best. If you do use rotation angle, use the rotation angle Y. But for now, I don't recommend using that. Then you have your LOD threshold. I have not added an entry for that within my data asset, but you could bind to that if you wanted to, or just set it to something like, 2 or 3 or something. But that basically is for performance. It'll disable this based off of the LOD of the character, which will increase performance. When you don't need the copy bone motion, copy it over. You could probably disable it if the character is far away, and you would likely not even realize. You probably wouldn't see a difference. You don't really need these right here. You're probably hardly ever going to want to apply these by a small amount. You're probably going to always... There might be situations where you actually want to turn it on and off during certain situations, but that'll be on you. Now let's go ahead and I'll show you guys this in action and how this stuff actually works in action. All right. It looks like my project is starting to lag. This is due to a memory leak in 5.8, I believe. Okay, it looks like it might be speeding back up. There's a memory leak in 5.8, and it keeps causing after it's open for too long, it'll start lagging. I don't know. It looks like it's lagging quite a bit to me. Let me see. I could probably close out of some of this. All right. It's still lagging. Okay, it might just be this viewport. For some reason, it might just... Okay. Anyway, we're going to set this to should move. And we're going to apply, I'm going to keep this actually in the debug mode 2. I don't think it matters because this isn't working for some reason. It was working yesterday, I promise you. At some point it stopped working yesterday for no real reason. And I think as soon as I restarted the project, I think it started working again. Let me try restarting the project. Yeah, this video is gonna be a bit long, but I want to make sure that you guys understand this because this is a very difficult thing to wrap your head around. It's confusing. Yeah, seems to be working fine now. Good. Yeah, it's just not working anymore. I don't know why. That's so weird. It was working yesterday, I swear. Actually, yeah, so we'll just do this. There we go. All right, so as you can see right here, we have a couple of different things. We have 3 different things going on here, actually, and you might only be noticing 2. So you have this gizmo right here. This is actually where, and when you set it to 2, just in case you didn't know, what you're actually seeing is you're actually seeing this neutral pose. So it's placing it in its space pose reference so that you can see how things are being moved around relative to the base pose reference that we're using. So that's what debug mode 2 is doing. And that's also probably why it doesn't work very well during runtime when you're in debug mode 2. But yeah, so that big gizmo right there that you see, that's actually the orientation and position of the actual bone to modify, which is the VB hand R primary. That's where it's actually at for this pose. So the one that's moving, the gizmo that you see moving around, that's actually the end result after we've copied the motion. That's how the virtual bone is going to move after we copy the motion out of here. I'm going to pause that. And I want you to look at this right here. You'll see an extra thing right here. This little yellow marker is actually the orientation of the rotation itself. I'm going to set this down to 25% speed. And all you need to do inside of here to get this is you need to go into your animation anim preview editor, which is over here. And you just need to set the ground speed to 600 and make sure you check should move. And you'll have to compile it after you change this, I believe. Yeah, so you want, because it's forcing us into the base pose, you won't actually see it falling. Okay, right. So this is how it's moving back and forth kind of along the Y direction, right? So this is the Y right here. I'm applying it 50% along the Y. If I apply it 100%, you'll see how it moves now. And let's just go ahead and zero this stuff out. And now with it only moving along the Y, you'll see it's moving in this direction. Now the reason why it's moving in this direction is because our copy space is actually the spine 05. So it's copying how the hand is moving relative to the spine 05. That's the delta would be the distance from this big gizmo to that little gizmo between across all those frames that you're seeing. Oh wait, no, I have the apply space set to hand R. That's why it's moving in this direction, because Y relative to the hand is in that direction. So if I reset that, then it's in component space. And now you'll see, I forgot I had done that when I was explaining this to you. So now you'll see that the Y is moving back and forth in component space. You can also set that to root, and it should basically move the same way. Now it's relative to the root. It just so happens that the root is aligned with the component space because it has no rotation applied to it. So if we want to reorient the Y movement, the Y motion that's being copied, that's where the translation offset comes in. So if you look at these different gizmos, then this will tell you what axis you need to rotate it around. So if we look at it from above, you'll see the up and down axis is the red, which is X. So if I add 90 to this, it should move it down here, I believe. Okay. Yeah, that's not actually what I was expecting. I think maybe it's because of the copy space. No? Let's temporarily remove this so that we can see the motion better and it happens faster. That should be the green, not the okay. Oh, because we are in component space, we need to ignore this. This I believe is just for the rotation. Ignore that. We need to pay attention to these axes right here because it is in component space. So 90, right. So rotating it 90 degrees along the component space Z will move it from going back and forth to going down here. And 180 will have it moving in this direction. 135, it'll be moving in this direction. You see? And so negative 180 and 180 is basically the same because this goes from negative 180 to 180, and negative 180 and 180 are both in the same place. Basically, both of those are equal to 360 degrees if you were treating it via those coordinates. And then negative 90 will have it moving in this direction. And then 45, it'll be moving in this direction. Right? Okay, you get the ideal, right? That's how you can, but you need to be real careful when you're doing this because, you know, if you're not careful, it's going to cause serious issues. So if we look at the X here and we rotate this around the X, which would be this axis here, it's kind of going more in this direction than the other direction, but yeah. So if we do 90, it'll move it from left to right to up and down. And then negative 90 will have the biggest movement going up, as you can see. And then if we look along the Y, it's not really moving it's not really moving relative to the Y. It's not moving like left or right, up and down. So, but if we do it like this, now it's kind of moving a little bit. Yeah, it's not going to have an effect as long as we do that. So we'll disable that. And we'll enable that. So now we can see that it's moving relative to the Y in component space. So if we do 90, it's kind of moving up. Negative 90, it'll be moving more down. And then 180, it'll be moving left to right. So you kind of get the idea, right? So what I was originally doing is I was originally inverting the X scale, which is the left to right, because the actual translation scale, that's relative to this X direction. So X is the movement left to right, Y is the movement back and forth, and Z is the movement up and down relative to component space. If we're in component space, I'm going to move the copy space back over to the spine 05 because it gives us, it makes the deltas less dramatic, as I explained to you before. Now, rotation scale is currently set to 1. I'm going to zero that out so that you can see this stuff. And you'll see how this is kind of moving left to right. And I believe that might be where these axes might actually come in. So the pivot will actually offset its location before it starts getting rotated. And the rotation will happen around this pivot right here rather than locally. So if you offset the pivot itself of this will swing around this instead of in place. You see, because you're taking that pivot and you're offsetting it. And so now it's rotating around, orbiting around this big pivot. That's basically how that works. Now this rotation offset right here will actually offset the direction in which it's rotating, I do believe. So if I do 180, you'll see that actually is relative to this big blue thing. So it went from rotating up here to rotating down here. And we can also offset the rotation around the Y. You see. And then there's not a whole lot of rotation around the X. It's kind of like moving all over around here. But you can invert that so that it's moving kind of around here. You see? So that's how that works. And if you combine these, say you offset it along the X, say 100 centimeters. And then you rotate it 180 degrees, you can get different results. But it's important for you to know that you're going to likely be using the rotation offset, rotation pivot, and translation offset. Use it very carefully. You're probably, I haven't found any real good use cases for it. It often causes more problems than it's worth, from my own experience. But yeah, that's basically how that works. And this is how you can use the debugger mode. And I haven't showed you the third one. You haven't really gotten to see that one yet. Let me show you the third one. The third one actually creates a trail, a motion trail, so that you can see actually the trail in which the motion uses. And so while you're doing this, you can say, all right, let's set this to 1. And now it's going from moving or orbiting around this to orbiting around this. So that this one might seem like it's more appropriate, but the thing is when you jump, your arms kind of tend to get pulled off to the right. And so that's the reason why I inverted it. I inverted it so that when you jumped, it would get pulled off to the left instead of the right. Because if it gets pulled off to the right, you'll have reaching problems on this offhand. And you don't have to do a full -1. You could do -0.5, so it's less dramatic. So you'll see that that motion path, it just got smaller, whereas before it was longer. Okay, that's basically it for the copy motion. I think I've done a pretty good job at explaining this. I definitely did a lot better job at explaining the rotation. The rotation is a lot more confusing than the translation. All right, so in the next video, I'm going to go over the copy bone advanced and the leg IK and why I'm doing this the way I am instead of it using 1. So I'll see you in the next video.